Welcome to KS Maths Tuition. Let us pass through the Fourier series part 5. Here today I am going to explain the Fourier series of 12 periodic functions. Actually this period of 12 functions already explained in my first video. Again, what I can say, the Fourier series of 12 periodic function, then that means the function is defined in the interval of minus L to plus L, or we can say the function is defined in the interval 0 to 2L. Okay. So f of x is equal to a0 by 2 plus sigma n equal to 1 to infinity n cos n pi x by L plus bn sin n pi x by L. This is the Fourier series of the function defined in the interval minus L to plus L. Then f of x is equal to a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L, where a0 equal to if the function is defined in the interval minus L to plus L, then period equal to 2L. Therefore, L is 2L equal to L. That means, therefore, 1 by L, a0 equal to 1 by L, integral minus L to plus L, f of x dx, a0. Then, an is equal to 1 by L, integral minus L to plus L, f of x cos n pi x by L dx. Okay. And bn equal to 1 by L, integral minus L to plus L, f of x sin n pi x divided by L into dx. If the function is defined in the interval minus L to plus L, then fx is equal to a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L, where a0 equal to 1 by L, integral minus L to plus L, f of x dx, and n is equal to 1 by L, integral minus L to plus L, f of x cos n pi x by L dx, and bn equal to 1 by L, integral minus L to plus L, f of x sin n pi x by L dx. Okay, this is the period of 12 functions. Okay, let's pass through some problems. Please read the question. Find the Fourier series of the function f of x equal to, tell me.
0 if minus 2 less than x less than 0.
Minus 2 less than x less than 0.
1 if 0 less than
x
less than 2.
Okay. Find the Fourier series of the function. Find the Fourier series of the function f of x equal to 0 if minus 2 less than x less than 0 and 1 if 0 less than x less than 2. We find the Fourier series of the function fx equal to 0 if minus 2 less than x less than 0, 1 if 0 less than x less than 2. Here period is equal to 4, 2 minus of minus 2, 4. That is 2L is equal to 4, therefore L equal to 2. Here 2L equal to 4, therefore L is equal to 2. Okay, but 2L period equal to 4, 2L equal to 4, that is L equals 0. So we can apply this formula. First of all, we have to find out a0, an and bn. Here L is equal to 2. Then a0 equal to 1 by L. 1 by L means 1 by 2 integral minus L to plus L. Instead of minus L to plus L, we can substitute minus 2 to 0, f of x 0 dx, and plus integral 0 to 2 1 dx. a0 equal to 1 by L, integral minus L to plus L, f of x dx. That means a0 equal to 1 by 2 into minus 2 to 0 0 dx and 0 to 2 1 dx. Integral 0 dx means 0. Integral dx is equal to x. Integral dx equal to x. Limit to 0 to 2. 1 by 2 into 2 minus 2 is equal to 2 minus 0. 2 minus 0. 2 minus 0 is equal to 2 by 2 equal to 1. So we can write a0 is equal to 1. Okay. And pass the second point. N is equal to, here also 1 by L. 1 by 2 integral minus 2 to 0 cos n pi x by L. L means 2 dx. And again integral 0 to 2, f of x 1 cos n pi x by 2, L means 2 dx. Okay, that means this part is 0, so we can delete and take this integral 1 by 2 into integral of cos n pi x, that is sin n pi x divided by 2 whole divided by n pi by 2, limit 0 to 2. Okay, that is integral sin n pi x by 2 divided by n pi by 2. Apply the upper limit and the lower limit. Okay, upper limit is equal to sin n pi x by 2, sin n pi by 2. That is n is equal to, that is 1 by 2 into 2 by n pi, 2 by n pi into upper limit sin n pi into 2, 2 by 2 equals 0, 2 by 2 equal to 1, sin n pi minus lower limit sin 0 0. So we can write sin n pi equal to 0, sin 0 0. So answer equal to 0. N is equal to 0. Okay. S 0 equal to minus 2 to 0, 0 dx and 0 to 1 dx. Into dx is equal to x. 2 minus 0 equal to 1. S 0 is equal to 1 and n is equal to 0. Okay. And then Bn. Bn is equal to 1 by L. 1 by L means 1 by 2 into integral minus 2 to 0, 0 sin f of x sin n pi x by L. Sin n pi x by L means sin n pi x by 2 into dx plus integral 0 to 2 1 sin n pi x by 2 into dx. The first part is 0, so we can delete that term into sin integral of sin n pi x minus cos n pi x by 2 divided by n pi by 2. Okay, apply the limit 0 to 2. Okay, that is take its term reciprocal 1 by 2 into minus 2 by n pi. You have to take the reciprocal of the term minus 2 by n pi. Okay, and apply the upper limit so cos n pi and apply lower limit cos 0. Okay, cos n pi minus cos 0. We can cancel this term minus 1 by n pi into cos n pi minus 1 all raised n and cos 0 is equal to 1. Okay. Ready? Then substitute this value in this terms. F of x is equal to ready? S0 by 2. F of x equal to S0. S0 means 1. That is f of x equal to S0 means 1. 1 by 2 plus sigma n equal to 1 to infinity. The value of n is equal to 0. N equals 0. And Bn minus 1 the whole minus 1 by n pi into minus 1 by n pi out of minus 1 the whole raised to n minus 1 into sin n pi x divided by 2. Okay. That is a0 is equal to 1. A0 by 2 means 1 by 2. And n is equal to 0. So delete that n. And bn equal to minus 1 by n pi into minus 1 all raised to n minus 1 into sin n pi by x by 2. Okay. That is 1 by 2 into, we can take 1 by pi as common term, 1 by pi out of 1 by 2 plus 1 by pi out of sigma n equal to 1 to infinity, multiplying this minus with the whole term, that is 1 minus 1 all raised to n. Okay, into sin n pi x by 2 whole divided by n. Put n is equal to 1, 2, 3 etc. Put n equal to 1, 2, 3 etc. 1 by 2 plus 1 by pi into, when n equal to 1, minus 1 all raised to 1 minus 1. Okay, minus 1 minus plus 2 sin n pi when x is equal to 1 sin n pi by 2 sin n pi by 2 divided by 1 plus when n is equal to 2, that is sin n pi becomes as 0. So we can delete that term. Put n equal to 3 minus 1 all raised to 3 minus 1 plus 1 2 sin n 3 n pi by 2 3 n pi by 2 divided by 3. Put n is equal to 4. This becomes as 0. Minus 1 all raised to 4 plus 1 minus 1 0. Put n is equal to 5. Again that becomes as 2 minus 1 minus into minus plus 2 sin pi by pi n is equal to 1 sin pi x, sorry. When n is equal to 1, 2 sin n x sin n sin pi x sin pi x by 2. And here also when n is equal to 3, sin 3 pi x by 2. When n is equal to 5, sin 5 pi x sin 5 pi x by 2 plus etc. That is the expansion of this term. That is fx equal to sin, put n is equal to 5 sin 5 pi x by 2, 5 pi by x by 2. Here sin 3 pi x by 2. Whole divided by, we can write whole divided by pi. Okay. Put n equal to 1. Minus 1 all raised 1, minus 1 plus 2 sin pi x by 2 by 1. Put n equal to 3. Minus 1 all raised to 3, minus into minus plus 2 by 3 sin 3 pi x by 2. Put n equal to 5. Minus 1 all raised to 5 plus 1. Minus into minus plus 1, but 2 sin 5 pi x by 2 divided by pi. Next, so 2 sin 7 pi x by 2 whole divided by 7. Like this it will go. 2, 4, 6, 8, all terms becomes a 0. We get the odd number result. That is the series of this function. Ready? Okay. Yes, please read the question. Find the Fourier series of the function f of x equal to
minus x minus 2 less than or equal to x less than 0 x 0 less than or equal to x less than 2.
Yes. Find the Fourier series of the function f of x equal to minus x minus 2 less than or equal to x less than 0 and x 0 less than or equal to x less than 2. Okay. Here also period 2l equal to 2 minus of minus 2 4. Therefore l equal to 2. 2l equal to 4, l equal to 2. Then we have, instead of, in this case, instead of l, we can substitute l equal to 2. Okay. So s0 equal to 1 by l integral minus l to plus l f of x dx. Then s0 equal to 1 by 2 into integral minus 2 to plus 2 f of x dx. Okay. That is 1 by 2 into integral minus 2 to 0 f of x minus x dx and integral 0 to 2 x dx. Ready? That is 1 by 2 into integral of minus x square by 2 limit minus 2 to 0 x square by 2 limit 0 to 2. Apply upper limit and lower limit. Minus of 0 1 by 2 out of 0 minus 2 square 4 plus 1 by 2 into 4 minus 0. Okay. Minus of minus equal to plus, that is 4 by 2 plus 4 by 2. 8 by 2 equal to 4, 4 by 2 equal to 2. That is s0 is equal to 2. The value of s0 is equal to 2. Okay. s0 equal to 2. Ready? And pass the second point n. N is equal to 1 by l. 1 by l means 1 by 2 integral minus 2 to plus 2 f of x cos n pi x by 2. Here l equal to 2. Therefore the formula becomes as 1 by 2 into f of x cos n pi x by 2. That is 1 by 2 into integral minus 2 to 0 minus x cos n pi x by 2 dx and plus integral 0 to 2 x cos n pi x divided by 2 dx. Okay. By applying the tabular integration by parts, we can integrate this term very simply, or very easily we can calculate this term 1 by 2 into, by using tabular integration method, first function into integral of second sin n pi x by 2 divided by n pi by 2. Okay. Minus the derivative of minus x minus 1 and integral of this minus cos n pi x by 2 divided by n pi by 2. So this becomes as n square pi square by 4. Then this answer equal to this equal to minus 2 to 0. Okay. And next step also we have to apply integrate this tabular integration by parts. First function x into integral of cos n pi x sin n pi x by 2 divided by n pi by 2. Okay, minus derivative of x 1 integral of this minus cos n pi x by 2 divided by n pi by 2. So this becomes as n square pi square by 4. Limit 0 to 2. Okay. Then apply the upper limit and lower limit. That is 1 by 2 into minus 2x by n pi into sine n pi x by 2. Okay. This comes in numerator. Then 3 minus becomes as minus 4 by n square pi square cos n pi x by 2. Limit minus 2 to 0. Okay, minus 2 to 0. And again plus this also 2 by n pi x sine n pi x by 2 minus into minus plus 4 by n square pi square cos n pi x by 2. Okay, ready? Limit 0 to 2. Apply the upper limit and the lower limit. Then 1 by 2 into, when we are applying the upper limit, 0, this term becomes a 0. Put x equal to minus 2, minus sine 2 and 2 cancel, minus sine n pi. Even then sine n pi equal to 0. Value of sine n pi 0, sine 0, 0. So we can say, if we are applying upper and lower limit, this part becomes a 0. 0 minus 4 by n square pi square. Next term, cos 0, 1. Minus cos minus theta cos theta, so we can write cos n pi. Okay, minus 4 by n square pi square into, when we are substituting x equal to 0, cos 0 1. When x is equal to minus 2, 2 and 2 cancel, cos minus n pi. The cos is an even function, so we can write this is equal to cos n pi. Upper limit minus lower limit plus. And the next step, here also we have upper limit, sin n pi 0, sin 0, 0. In this case, upper and lower limit are 0, so answer equal to 0. Plus 4 by n square pi square into upper limit cos n pi minus cos 0, 1. Okay, cos n pi equals 0. Then we can simplify this term. So we can write this an equal to, take 4 as a common term, 4 by 2. 4 by 2 pi square out of 4 by 2 pi square out of this minus into minus 1 minus 1 minus 2, and then minus into minus plus cos n pi plus cos n pi 2 cos n pi. Okay, we can take 2 as a common term, then cancelling this term it becomes as 4 by pi square into the value of cos n pi minus 1 all raised to n minus 1. That is the value of n. An is equal to, we can write here, an equal to 4 by pi square minus 1 the whole raised to n minus 1. Minus 1 all raised to n minus 1. A0 is equal to 2 and n is equal to 4 by pi square minus 1 the whole raised to n minus 1. Ready? Okay, this is equal to this minus 4 minus 1 minus 1 minus 2, that is this minus into minus plus cos n pi plus cos n pi 2 cos n pi. Take 2 as a common term, we can cancel this, then 4 by pi square. The value of cos n pi minus 1 all raised to n and this minus 1. So it is n equal to 4 by pi square minus 1 all raised to n minus 1. Okay, yes, then pass to the point Bn. Here a0 is equal to 2 and n is equal to 4 by pi square into minus 1 the whole raised to n. Okay, next passes through Bn. That is Bn is equal to 1 by L 1 by 2 integral minus 2 to plus 2 f of x sin n pi x by L. L is equal to 2 sin n pi x by 2 dx. Okay, that is 1 by 2 into integral minus 2 to 0 minus x sin n pi x by 2 dx plus integral 0 to 2 x sin n pi x by 2 dx. Ready? Then here also we can apply tabular integration by parts. Okay, first function into integral of second, that is first 1 by 2 as a common term. First term minus x into integral of second, integral of sine minus cos n pi x by 2 divided by n pi by 2. Okay, minus integral of minus derivative of this one minus 1 integral of this minus sin n pi x divided by 2 divided by this n pi by 2. Therefore, this becomes as n square pi square by 4. And next plus derivative of minus 1 0. So integration is over. So we can write minus 2 to 0. Okay, this integration is known as a tabular integration by parts. Then here also we have to apply same formula. That is first function x into integral of sin n pi x minus cos n pi x by 2 minus derivative of x 1 and integral of this minus sin n pi x by 2 divided by n pi by 2. That means n square pi square by 4 limit 0 to 2. Okay, apply upper limit and lower limit. Before applying this limit, we can arrange this term. That is 1 by 2 into minus plus 2 by n pi x cos n pi x by 2 and minus into minus plus into minus 4 by n square pi square sin n pi x by 2 limit minus 2 to 0. Ready? And also this plus cos n pi x by 2 by n pi by 2. Yes, take this term 2 minus 2x minus 2x by n pi cos n pi x by 2. Okay, and this is minus into minus plus, that is equal to 4 by n square pi square pi square sin n pi x by 2 n pi x by 2 limit 0 to 2. Okay, here by applying integration by parts, tabular first function into integral of second minus cos n pi x by 2 by n pi by 2 minus derivative of x1 and integral of this part minus sin integral of cos sin n pi x by 2 by n pi by 2. Therefore, this becomes as n square pi square by 4. Applying the upper limit and lower limit, that is 1 by 2 into put 2 here 0 becomes as this term 0. Okay, this 0 and here also sin 0 that is upper limit. Applying the upper limit, both the term becomes as 0 minus apply lower limit minus 2 into 2 minus 4 by n pi minus 4 by n pi cos n pi into minus 2 and 2 cancel cos minus n pi, then there is cos n pi is an even function, so we can write this is equal to cos n pi. When x equal to minus 2 into 2 minus 4 cos n pi into minus 2 by 2, we can cancel 2, then cos minus n pi equal to cos n pi. Okay, cos n pi minus sin n pi, that is also equal to 0. Okay, and here also apply the upper limit 2 into 2 4 by n pi cos n pi. And next sin n pi, that is also 0, and lower limit x equal to 0, here also 0, so this terms becomes as 0. Okay, apply the upper limit 2 into 2 4 by n pi cos n pi into 2 by 2 cancel cos n pi, then when x equal to 2 sin n pi equal to 0. Lower limit, when x equals 0 this equals 0, when x equals 0 sin 0 equals 0, so it will cancel. Then minus into minus plus 4 by n pi cos n pi and 4 by cos n pi. Here also one minus sign is there. Okay, we arrange this term, minus is on, that is here contain minus term. Okay, this minus 2x by n pi minus 2x by n pi, so this becomes as minus 4 by n pi minus into minus plus 4 by n pi cos n pi minus 4 n pi cos n pi equal to 0, so we can say that bn equals 0. 1 by 2 into minus plus 4 by n pi cos n pi minus 4 by n pi cos n pi 4 by n pi cos n pi. The value of cos n pi we can cancel, then we can write bn equal to 0. S0 equal to 2, an equal to 4 by pi square minus 1 alteration minus 1 and bn is equal to 0. Bn equal to 0. Okay, what will do? We have to apply this value in this equation. That is f of x is equal to a0 by 2, f of x equal to a0 by 2 by 2 plus sigma n equal to 1 to infinity n 4 by pi square into minus 1 the whole raised to minus 1 into cos n pi x by 2, L means 2 and Bn is equal to 0. We can delete that term. Okay. Then fx equal to s0 by 2. S0 means 2, 2 by 2 plus sigma n equal to 1 to infinity 4 by pi square into minus 1 all raised to minus 1 into cos n pi x by 2. Put n equal to 1, 2, 3. That is 1 plus 4. We can take 4 by pi square as a common term. 4 pi square into, we can put n equal to 1, minus 1, minus 1, minus 2. Cos n is equal to 1, cos pi x by 2. Okay. Plus, put n equal to 2, minus 1 all square, plus 1, cancel. Put n equal to 3, minus 2, cos 3 n pi, 3 pi x by 2. Okay, 3 pi x by 2. Similarly, when n equal to 4, it will cancel. When n equal to 5, minus 2, cos minus 2, cos 5 pi x by 2, cos 5 pi x by 2 plus etc. Then what do you do? We have to take minus 2 as a common term. So we can write this is equal to 1 minus 8 by pi square into cos pi x by 2 plus cos, minus, take minus as a common term. Then this becomes as cos 3 pi x by 2 and again plus cos 5 pi x by 2. Okay, plus etc. That is the series of this expansion. Yes. The final answer is 1 minus 8 by pi square. 1 minus 8 by pi square into cos pi x by 2 plus cos 3 pi x by 2 plus cos 5 pi x by 2 plus etc. Okay. Yes. That is Fourier series of 12 periodic functions is over. Next video we will take the Fourier series of even and odd functions. Thank you.